C of JWST.
Europa is a big target for NASA exploration because we have very high evidence that there is some subsurface, maybe water reservoirs on Europa. We took the data from Europa a few weeks ago. Maybe I think Europa was like 10 days ago. So the data just came out from the telescope raw, and it actually became public immediately the moment we saw it. And we got these email alerts and said, oh, the data's there, the data's there. And then you go to the data and it looks like, very tricky because it's raw data, pixels to pixels. So you spend nights and working on the data, everybody's working, oh, what is there, what is there? And now today, we didn't know what to do about the meeting. Should we wait for the paper or should we make it public? And then say, look, the data is public, let's tease people also because they see this cool data, maybe astrobiologically relevant or habitable or maybe potential for life.
Jupiter is the largest planet in the solar system, and if people have a mental picture of Jupiter, they might think of it with its great red spot. And the planet Earth could easily fit inside that great red spot. In fact, you could fit 2 Earths inside the great red spot. So it's a much, much larger planet than the Earth. And it's a fundamentally different kind of planet. We call it a gas giant because when you look at Jupiter, all you see is swirling gases. And if you could strip away that outer layer of gases, like by magic, underneath it you would see more gases. And if you took away those gases, even more, it's gases all the way down. It doesn't have a solid surface with an atmosphere. It's all atmosphere until you get like deep, deep, deep into the core of that giant world. Galileo actually looked at Jupiter with his small telescope and made an astonishing discovery that there were tiny dots that seemed to be orbiting Jupiter. And this was the discovery of the 4 largest moons, which today we call the Galilean moons. And that was really crucial at that time because it was the first time we had evidence that our Earth was like not the center of things. Here was a system where other things were the center. Jupiter was the center of that system.
So when Galileo first discovered there were some moons around Jupiter, we didn't know anything about them. We just saw they were small, pretty bright, nearby, going around pretty fast around Jupiter. But then we were lucky to have a few missions to go through the systems. One first was Voyager.
Scientists at Cape Canaveral, Florida sent another unmanned Voyager spacecraft on its way to Jupiter and Saturn today. It lifted off flawlessly at 8:56 a.m. This Voyager presumably will get to Jupiter in March of 1979.
Dr. Smith, can you offer yet any kind of a historical scenario for the cracks on Europa? Why they're there?
No, Rick, I cannot. I'm sorry. No, I think we really, we've had these pictures in hand for something like 24 hours or so, and I think we really don't begin to understand these features that we're seeing on Europa. It was no surprise that we should be surprised. Europa looks very different from the other satellites.
And they had remarkable surprises all throughout the Jupiter system.
And we got some very nice pictures in late yesterday afternoon and last night of the inner 2 satellites, Io and Europa, which I'd like to share with you. And it looks very unlike any of the other satellites in the style of the contrast we're seeing, and also quite unlike any other planet we've seen. For instance, you don't see lots of dots or large, irregular, circular-shaped regions of darker material. What you see is more or less fuzzy boundaries, and then these rather sharp, semi-linear features that sort of reminiscent of fracture patterns or something of that sort. And these are big features. They maybe between 50 and 150 kilometers across. They're several thousand kilometers long.
Years later, it was a spacecraft named after Galileo himself that was put into orbit around Jupiter.
The spacecraft is stable. Galileo is on its way to another world. It's in the hands of the best flight controllers in this world. Fly safe.
And this was a challenge spacecraft because its main antenna didn't open.
Galileo certainly was the most problem-plagued interplanetary project ever.
We had this spacecraft that we couldn't touch. It was so far away, and it had such a huge hardware problem.
We had this high-gain antenna failure, we had the tape recorder. All throughout, we had one adversity after another.
And so they had to use one of the small antennas on the spacecraft to relay data back. But even so, it had new instrumentation, particularly at infrared wavelengths that we didn't have before. So it revealed a lot of new details about Jupiter and how it changes.
When the first image is taken from Galileo, the surface of Europa, first of all, you see the cracks everywhere, but you also see these veins of some material being exposed. Below this crust of ice, which is primarily water, there is a subsurface ocean.
Good afternoon. My name is Dwayne Brown with the Office of Communications, and welcome to NASA headquarters. Today's Science Update will feature new theories concerning Jupiter's icy moon Europa. In fact, what you will hear today opens up compelling possibilities in the search for life elsewhere in the universe.
The Galileo orbiter in the late 1990s detected the magnetic signature of an ocean underneath the ice crust, a liquid water ocean. It did this using a technique that is somewhat similar to the way that metal detectors work, for example, at a beach. Looks for things that are electrically conductive, and a liquid water ocean with salt in it is quite electrically conductive compared to ice.
So Jupiter is 5 times farther from the sun than Earth is, and so we are just so surprised that we were able to, that far out from our host star, find a world like Europa that's able to maintain a subsurface ocean. That's not something that we expected to see. We're able to again maintain that ocean because of Jupiter's gravitational tug on Europa and that tidal heating, but this is something that's really special. It's really special to find liquid water on a moon that is so far away from the parent star in the system.
I think Europa is one of the most interesting places in the solar system because it probably has more liquid water than all of Earth's oceans combined. And when we think about the possibility of habitability beyond Earth, the possibility of life elsewhere in the solar system, we want to follow the water. So Europa is a super exciting place to me, and I think to many other people.
Jupiter is a big planet, so it has a strong gravitational field. So it easily holds in check all of the moons that surround it. And frankly, I lose track of how many moons there are because new ones are discovered all the time. Maybe it's 60, 70, 80, 90. I don't even know anymore because there's so many of them. But the major moons, the large ones like Io, Ganymede, Callisto, Europa, those moons are big. They're worlds in their own right. And because they're large, they interact with one another. And they get into what we call resonances. And that means sort of like for 2 times around this moon, the other one does 3 times around, and then they line up. And every time they line up, there's extra gravitational pull on them because of the moons and because of Jupiter's strong gravitational pull. And that tidal pumping that happens from these resonances, we know warms up the interior. You have what should be ice ball moons actually turning into melted rock moons or liquid ocean moons.
We are now less than a minute away from the end of the mission.
So once the mission was nearly done, once the spacecraft was nearly out of maneuvering fuel, just to be safe and prevent it from crashing into Europa and potentially contaminating that ocean with spores, the spacecraft was redirected into Jupiter, where it burned up into its component atoms.
We are counting down here in space flight operations. The final moment, the great mission, Galileo is gone.
We sacrificed Galileo to save Europa.
Atlantis, Houston, you are...
Most interesting to understand how Jupiter changes over time has been the incredible more than 30 years record from the Hubble Space Telescope.
Houston, Atlantis. Hubble has arrived on board Atlantis with the arm.
Atlantis, Houston, we copy. Nice job, Megan. Nice job on the Proxap's flying as well. It's great to be back with the telescope.
Hubble isn't just a satellite. It's about humanity's quest for knowledge. I want to wish Hubble its own set of adventures, and with the new instruments we've installed, that it may unlock further mysteries of the universe.
We have been studying Jupiter regularly for decades now with the same telescope, slightly different instrumentation, but generally the same. And that has allowed us to learn things like that great red spot has actually been steadily shrinking over time. We could see that in the Hubble images over the decades that we observed it. And so the need to continue observing with ever more powerful tools until we get a new mission there, that has only intensified over the years.
And we have engine start and liftoff. Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
Well, I'm thrilled to see that it finally worked, because when we started off, we got a lot of people laughing at us that was impossibly difficult, and now it's done.
And we have a fully deployed JWST observatory.
Well, my dream when I wrote a proposal to NASA to use what was then called the Next Generation Space Telescope to study the solar system, my dream was that it would be a broad program and that we would be able to use this telescope to do many different things. That was a dream. What's so exciting now is this dream is reality. We do now have all these observations from the near-Earth asteroids all the way to the edge of our solar system. And they're all fantastic. They just surpassed my expectations of what they would be. So it's a really exciting time to be a planetary scientist using JWST. We have sent a lot of spacecraft to Jupiter. We orbited Jupiter with Galileo for many years. We currently have an orbiter there called the Juno spacecraft. So you might wonder, like, what could we ever learn with the telescope that we haven't seen when we're right there? The answer is, with a new facility like Webb, you actually can sense different altitudes in the atmosphere than you can with the cameras on the spacecraft that were there in the past and are currently there right now. And by looking at the different altitudes, you can pull out new features.
When we think about the ring planet in our solar system, we immediately think about Saturn. But who else you think has rings? And this is Jupiter, that we tend to never see those rings. So with James Webb, what we did, we actually exposed the planet an incredible contrast to actually map their tenuous rings around it. And you can see here this beautiful image of Jupiter, which is fascinating, but you can also see this tenuous ring forming around Jupiter. This is like a small debris of the moons that actually form this debris and makes a little ring. And you can only achieve that with James Webb because it has this dramatic contrast. Being an infrared telescope, you can map certain colors which are more difficult, and being a big telescope with that spatial resolution, you can actually achieve that in beautiful contrast for the rings.
When I am anticipating what we're going to see, I have some ideas in my head. You know, I know we're going to see some images, I know we're going to see some spectra, but the real excitement is We don't know exactly what we're going to see because the sensitivity is so much better with James Webb Space Telescope, and the spectral resolution is so much better.
Europa probably has beneath its icy surface a global ocean of water. Everywhere on Earth that there's water, there's life. So we want to understand, could Europa be a place where life might exist today? Does it have the ingredients that could potentially support life?
The ocean is so meaningful for life on Earth, and it brings such a sense of massiveness. And I think once we get to Europa, like thinking about this subsurface ocean, it's not quite the same as we think of oceans on the Earth where you got waves and such, but we also need to step back and look at it as this is a world with an ocean, possibly with habitable environments, and to be able to think about that as a connected system again, just like on the Earth, and the kind of the massiveness of that, and also how that then will tell us about other bodies in our solar system or other bodies outside of our solar system.
The question of plumes on Europa has bedeviled us for a while now. The Hubble Space Telescope looked at Europa in the ultraviolet, and they saw evidence for oxygen emission and hydrogen emission near the edge of the moon, and they're thinking, well, this is probably due to water, and so probably evidence of some kind of plume activity. But it wasn't there every time they looked. Sometimes it was there, sometimes it wasn't there. And so, controversial. There was a reanalysis of Galileo data, and the Galileo also hinted that there was some kind of potential activity there. But again, it wasn't definitive. Europa was a key target for us with JWST to look to see if we could see a plume because we have such great sensitivity. We did not see a plume at Europa with JWST. We saw other interesting things, but not a plume. Does that mean it's not there? Maybe, maybe not. Maybe this plume is episodic. Maybe there's only certain configurations where it is active.
So I first got excited about using JWST when I was a grad student at Caltech. I hadn't launched yet, it wasn't available yet, but the build-up was so exciting. We were really interested in this question of the CO2, which you just cannot access through Earth's atmosphere. JWST gives us access to all of those wavelengths that we can't access through Earth's atmosphere. So there were two independent teams looking at this Cycle 1 JWST observation of Europa, and so we downloaded it as soon as it was available. I think it was right after Thanksgiving. I was actually at my parents' house. In between, making stuffing and carving the turkey, I was looking at these data and trying to test if our prediction was true. And it turns out that it was, so it was very exciting. The significance of this carbon result is that it's really another data point on what actually is probably within Europa's internal ocean.
And that's the main idea. Is that ocean habitable? We needed to find where the carbon was stored, and if there's a carbon source on Europa, especially in the ocean.
People think as an astronomer that you spend your life, especially your nights, outside at your telescope. I guess they think you have one at your house or something, I don't know. But when you're using professional telescopes, you typically get a tiny piece of time, maybe 45 minutes for the year, maybe 2 hours for the year. That's not a lot of time. And so there's a lot of questions that you can't answer when you only have tiny snapshots. That's the data that you get, and that's what you work with. It'll take a lot more observations, and it might have to wait until we get spacecraft back in the system.
So Europa Clipper is NASA's flagship mission to Europa, and it has everything on there that you would want as far as instrumentation to be able to study a moon and to figure out what's going on there as far as the geology, what's going on in the interior. And my role on Europa Clipper is as a team member on the Europa imaging system, and so that's the camera team. And so what we're going to do is try to take high resolution images of Europa's surface, higher than we've ever had before, and we are also going to look for the guidance geyser-like plumes that the Hubble Space Telescope has observed and see if we can image those up close. So it's really full circle going from Voyager to Galileo with a little bit of the Hubble Space Telescope mixed in, JWST, and now Europa Clipper. So we're very excited. In October 2024, the Europa Clipper spacecraft is going to launch from Cape Canaveral and it's going to be on its way to the Jupiter system. The fractures on Europa, some of them are thousands of kilometers long, and if you look at a picture of Europa's surface, they're just crisscrossing the surface. I mean, these are not just small fractures. These are fractures that would put the Grand Canyon on Earth to shame. So these are just massive fractures, and again, many of them form because of tidal heating, because of the gravitational pull of Jupiter on Europa. So that just shows you how powerful Jupiter is and how much bigger it is in Europa. So we have organics, we have water, and we have energy, 3 of the necessary ingredients for life. So Europa looks like a good place to look for habitable environments.
So now that we know that there is a carbon source, now we can go deeper, and I think it will help a lot with Europa Clipper and more observations, deeper integrations with James Webb. We are allowed to see other carbon compounds, for example methane or ammonia, which is an antifreeze. So as we now looking for more compounds, we can learn about the chemical diversity and some other processes that help with the habitability of the surface and the ocean.
We were so honored that the National Poet Laureate Ada Limon wrote a poem about Europa and Europa Clipper.
Arching under the night sky, inky with black expansiveness, we point to the planets we know. We pin quick wishes on stars. From Earth, we read the sky as if it is an unerring book of the universe, expert and evident. Still, there are mysteries below our sky. The whale song, the songbird singing its call in the bough of a wind-shaken tree. We are creatures of constant awe, curious at beauty, at leaf and blossom, at grief and pleasure, sun and shadow. And it is not darkness that unites us, not the cold distance of space, but the offering of water. Each drop of rain, each rivulet, each pulse, each vein. Oh, second moon, we too are made of water, of vast and beckoning seas. We too are made of wonders, of great and ordinary loves, of small invisible worlds, of a need to call out through the dark.
The collaborative experience of being on Europa Clipper is pretty amazing. You have scientists who were around when the Galileo spacecraft, who were actually on, team members on the Galileo mission, and so they have this vast amount of knowledge about Europa, and any question, just about any question you ask, they could answer, and so it's so amazing. But then you have those of us who, when the Galileo spacecraft was at Europa, who were in middle school. When we come in, we have these new ideas, and so just the mesh of the folks with the wisdom and the experience from the Galileo mission era, and those of us who are newbies and kind of coming in and having mentorship from them, but also having our own ideas, it's been really great. My first experience with science, at first I didn't really like science when I was in middle school or junior high school, as people call it, but I got to high school and I took a very, very good honors biology course, and so at that point I was pretty much stuck on biology. I wanted to have some sort of job where I could use biology. I wanted to be a marine biologist or a doctor or something like that, and that's the track that I wanted to go on. And then my junior year in high school, I took an earth science course where one of the units was astronomy, and so we learned about the life cycles of stars and how they die and they can go supernova and some of them become black holes, and I was hooked, and I could not believe that people actually got paid to study things that were that cool. And along the way, I spent a summer at the Johns Hopkins University Applied Physics Lab studying Europa and completely fell in love with planetary science, and I really fell in love with Europa.
So we have all these missions going there to explore these moons in detail, but where are we going to go? What are we going to find? What is the best way to explore these moons? One day maybe sending humans to Europa.
People have thought about, what might life on Europa look like? Of course, on Europa, there's no sunlight penetrating through that ice shell, for photosynthesis in the ocean. So it has to be life that's independent of sunlight. And on Earth, the most analogous environment is probably hydrothermal vents at the seafloor. So places where seawater is interacting with seafloor rock.
2023 has been an amazing year for JWST. It has seen so much science starting to pour out of the telescope and into papers that are now being published. So what an exciting time for someone like me who's been waiting and watching for 20 years. This is the year where the science has started to flow.